Hey everybody, have you ever wondered what was meant by the term glass cockpit? Pilots talk about operating the aircraft and they talk about the glass cockpit. I don't know. Is that anything like a glass house? Well, not exactly. Let's talk about that today. Here we are at the Epic Flight Academy, and this is the instrument rating course. I'm your host, Mike Thompson, and remember, to be successful in this course, there are 3 keys. Now, we are so glad you're here watching these videos. That's one part. But another essential part is to study Epic's online instrument rating course, and then thirdly, review all of this content one-on-one with your flight instructor. So, what about that glass house, that glass cockpit? Well, a glass cockpit refers to an electronic display of flight instruments. Now, several different companies put out equipment like this, and we want to spend just a few moments orienting you to what we call the G1000. This is Garmin's product, or Garmin's version of the glass cockpit. The G1000 system consists of multiple LRUs. That's Lima Romeo Uniform. Well, what it really means is line replaceable unit. And LRUs came on the scene along with glass cockpits, and the value of an LRU is, if there is a discrepancy by the flight crew, the maintenance crew can simply remove that unit, replace the unit, send the aircraft on its way, and then correct the discrepancy within that particular unit. This keeps the aircraft flying. And that's what we mean when we say LRUs. Now, these LRUs perform different functions and collect different data sets to be displayed to the pilot on this glass. Now, in Garmin's case, we have 2 in the Cessna 172S model, and we call these the PFD, that's the primary function display, or the MFD, the multi-function display, and you can see a graphic of those right here. Now, those 2 units are identical in that they are both the Garmin's GDU 1040. The only way they differ is in what is displayed on them. Now, in the Garmin G1000 system, we actually have 7 LRUs on board the airplane. And it's not too hard to think of it if you take a look at this graphic right here. The air data computer is collecting, well, you got it, data about the air. Now, I want you to think back to the pedostatic system. The pedostatic system was all about air data. The air data computer really just replaces your old pedostatic system. Now, remember that the unit itself is digital, but it still must collect analog information. So this air data computer, while it displays digitally, is still collecting data from the pitot tube, the static port, etc. The second one is the AHRS, we say for short. That's AHRS, or Attitude Heading Reference System, and that, in short, just replaces the old gyroscopic system. Then we have the magnetometer, which helps the direction indicator maintain its heading. And then we have the engine airframe unit that collects data from the engine and the airframe. Well, like what might I be interested in? From the engine? Oh, how about RPM, oil temperature, oil pressure, etc. The airframe? Well, let's see, what data do I want from the airframe? Fuel quantity, things like that. And then we have 2 avionics units, or GIAs, 1 and 2. That's avionics 1 and 2. That's 6 LRUs. And then finally, the 7th one is the GTX, or transponder. Now, let's take a look at each of these in just a little bit more detail. That air data computer is referred to as the GDC, that's Garmin Data Computer 74. And you can see a picture here of what it looks like. You can see a picture of the PFD and what it displays, and also shown is a picture of what these LRUs look like when they're mounted in your aircraft, and the GDC provides to the pilot airspeed, altimeter, vertical speed, and outside air temperature. Now, taking a look at this AHRS in a little more detail, remember we said that it replaces the old gyroscopic system? Well, take a look at the information it's going to provide you. The attitude, that replaces the old attitude indicator, rate of turn, the slip skid information or the inclinometer, and heading. Now, that heading information is provided particularly by the, can you remember what we talked about? The magnetometer, exactly. That's the GMU44. And you can see a picture of that here, that GMU44 providing info to the AHRS, that's the GRS77. You can see those right here. Now, I want to show you a close-up of that GMU. That GMU is about the size of a large cup, and in the 172S, it's mounted out in the left wing. Now, I want you to take a look at this graphic and understand exactly how this GMU operates. This magnetometer has 3 bars, and you can see them here in the graphic. Notice that bar straight ahead aligns to the aircraft nose, and you see the nose pointed straight up, or let's say we're flying north. And right next to it, do you see how we've turned the aircraft 90 degrees? Let's say this aircraft is flying east. The bar is still in the same place. That magnetometer maintains the same orientation as the aircraft because it is literally bolted into the left wing. So when the airplane turns, the magnetometer turns. Now, here's the interesting part. Notice on each of those 3 spokes, we have multiple windings of fine wire. And notice these black lines that come vertically through the magnetometer here. Those black lines are representing the Earth's magnetic field, or lines of flux. Now, here's the interesting part. When those fine windings interact with magnetic flux lines, a small electrical current is generated. This is a principle called electromagnetism. Now, take a look at our aircraft flying north. Those flux lines are passing through those coils in such a way that they generate a certain voltage, and our engineers convert that into a heading. Notice in the picture as the aircraft turns east, those same flux lines are passing through those same coils, but there's a different concentration of flux lines in each coil. This is going to generate a slightly different amount of current, and again, our engineers will convert that into a heading, and that will be a different heading. So, the magnetometer is able to allow the heading indicator to maintain its heading automatically without being reset. So when we look at this G1000 then, let's finish with this overall schematic. And you can see the GDU 1040. That is the PFD and the MFD. Remember, they have different displays, but it's the same unit. Then we see the GMA 1347, that's the audio panel. Now, remember, as you come down, the GDC, Air Data Computer, pitot-static system, GRS, attitude heading, that's the old gyroscopic system, and feeding into that is our GMU44. You see that? Left and right is GIA 1 and 2. That's avionics 1 and 2. And then finally we have the engine airframe and the transponder. So if you kind of think big picture and study that schematic, you see this G1000 is designed pretty efficiently. And it's designed with a level of redundancy so that if any system fails, it does not cause a total loss of the other systems. Well, folks, that's a quick review of the G1000. Join us next time.